Hi everybody, Mrs. Pesic here. We're looking at summer video number 3, radicals and their properties. So let's recall what is a square root. A square root of a number is one of its two equal factors. So for example, 7 is a square root of 49 because 49 has 7 as its factor twice. So 7 times 7 gives us 49. Negative 5 would be a cube root of negative 125 because negative 5 when raised to the third power is going to give us negative 125. All right, so that's an example of a square root and a cube root. Here's our definition. Let a and b be real numbers and let n be greater than or equal to 2. And let that be a positive integer. So if a is equal to b raised to the n, then b is an nth root of a. If n equals 2, the root is a square root. If n equals 3, the root is a cube root. All right, note, some numbers have more than one nth root. 49, for example, has 2 different square roots, namely 7 and negative 7. So why do we say that? Because 7, when squared, gives us 49, and negative 7, when squared, also gives us 49. The principal square root is going to be positive 7, though, because positive 7 has the same sign as positive 49. So here's our notation for a square root. We use this symbol. This little number here is known as the index, right? So in this example here, I've got 4th root of 16. That's how we read that. The 4 is the index, and the radicand would be 16. Well, what is the 4th root of 16? Well, the 4th root of 16 is going to be equal to 2. Why? Because 2, when raised to the 4th power, is going to give me 16. Notice when we say square root of 49, we don't want to say, hey, that's equal to plus or minus 7. That's incorrect, because as soon as you make this symbol right here over the 49, you are implying only the principal square root, in this case the positive 7. So we would say square root of 49 is equal to 7. We could say the opposite of square root of 49 is equal to negative 7. All right, so let's evaluate these. What's the 5th root of negative 32? Well, this is really asking what number do I need to raise to the 5th power in order to get negative 32? So the answer here would be negative 2, because negative 2 times negative 2 times negative 2 times negative 2 times negative 2 is going to give us negative 32. So my answer here should be negative 2. How about this one? What is the 4th root of 81? Well, what number raised to the 4th gives me 81? Well, that answer is 3, because 3 times itself 4 times is going to give me 81. So my answer here is 3. How about this one? What's the cube root of negative 27 over 8? By the way, let's back up for a second. It's a-okay to have a negative number under the radical if your index is what? Odd. All right? If your index is even, no fair having a negative under the radical. So here my index is odd again, so I can have a positive number or a negative number under the radical. Well, really, to evaluate this, let's split this up into cube root of negative 27 over cube root of 8. That's one of our properties. Properties of radicals. Cube root of negative 27 is going to be the number that I would need to raise to the 3rd power. So what raised to the 3rd power gives me negative 27? Well, that's going to be a negative 3. So I get negative 3 in my numerator. And what number do I need to raise to the 3rd power to get 8? Well, that would be 2. So I get 2 in my denominator. So negative 3/2 would be my answer for letter C. Let's take a look at this one. How about the 4th root of negative 16? Well, in this case, my index is even, but I have a negative number under the radical. So what number could I raise to the 4th power and get a negative 16? Well, there's no number that I could raise to the fourth power to get negative 16. So in this case, there's nothing here. So we're going to say not a real number. All right, so no real solution there. All right, so it might be helpful to have a list of perfect squares, cubes, fourths as we are going on in this video. So for your perfect squares, 1 squared is 1, 2 squared is 4, 3 squared is 9, and so on. So we can build up this little list of perfect squares for us. All right, and perfect cubes, well, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, so on. All right, we can keep going here, we can keep going here. And then what about perfect fourths? Well, 1 to the fourth is 1, 2 to the fourth is 16, 3 to the fourth is 81, 4 to the fourth is 256, 5 raised to the fourth power is 625, and so on. We can keep going with these lists. All right, so kind of keep that in mind. You might want to refer back to that. So let's talk about some properties of radicals for a moment. So one property is that if you have the square root of a times b, that's the same thing as saying square root of a times square root of b. And same thing if you have square root of a over b. We already used this one. We can rewrite this as square root of a over square root of b. So we're going to use these properties as we go on in simplifying radicals. So how do we simplify radicals? Here are the rules. Number 1, all possible factors have been removed from the radical. Number 2, all fractions have radical-free denominators, and I could add here that there's no fractions under a radical symbol. All right? And number 3, the index of the radical is reduced. Well, we're not going to worry about this one on this video. We might do some examples of that in class. But for right now, to simplify a radical, you're going to factor the radicand into factors whose exponents are multiples of the index. So in this case, we're trying to simplify cube root of 54. All right, so how would we simplify that? Well, think back to our properties, our powers of, let's try this again. Let's think back to our perfect cubes. Is 54 a perfect cube? No? Well, what are our perfect cubes? We listed them on the other page, but let me just write them here. 1, 8, 27, 64, and so on. Do any of these numbers divide into 54? Yes, 27 does. It goes in 2 times. So that means I really could write this as cube root of 27 times 2. And using the property of radicals that we just talked about, I can write this as cube root of 27 times cube root of 2. And what is the cube root of 27? Well, this is just equal to 3, because it's the third number down on the list. 1, 2, 3. It's the third root, the third one down. So cube root of 27 is 3 times the cube root of 2. All right, let's talk about how we can go from radical form to rational exponent form. Radical form is what we've been talking about. You've got some number here as the index, right? And you have some number here as a power. But if I want to go from radical form to rational exponent form, we're going to need to rewrite it so it's a same base of x raised to a fraction instead of under a radical. The power always becomes the numerator, and the index always becomes the denominator. So quick example here. So if I have, let's say, 5th root of x to the 4th, that could be rewritten in rational exponent form as x to the 4 over 5. All right, let's take a look at some examples. If we have the cube root of x to the 30th, and we want to simplify this, notice that 30 here is a multiple of our index 3. And that means that I can really rewrite this in rational exponent form as x to the what over what? Well, it's going to be x to the 30 over 3, which is x to the 10th. and that would be our solution here. What if I want to simplify 4th root of 96? Well, check back on your list of perfect fourths. Is 96 in that list? Well, let's look. Perfect fourth, I'm just going to remind you of some of the perfect fourths. 1, 32, 243, wait, those aren't perfect fourths. I'm sorry, 1, 16, 81, 256, 625, and so on. So do any of these numbers divide into 96? Well, only 16, so I can rewrite this as 4th root of 16 times 6. And so I can split this up into 4th root of 16 times 4th root of 6 using one of our properties of radicals. And so 4th root of 16 is really just equal to 2, so I get 2 times 4th root of 6 as my answer. Let's take a look at this example. Now I've got cube root of y to the 17th. Well, this power here is greater than our index, so it can be simplified, but I don't want to just write it as y to the 17 over 3, because that's not going to reduce to a nice integer, so let's not do that. Instead, let's look at the multiples of our index. So that would be 3, 6, 9, 12, 15, 18, 21, and so on. We want the largest number in this list, but it has to be less than our power. So that would put us at 15. So that means I want to split this up into cube root of y to the 15th, because that's that number, times cube root of what? How many y's would be left over? Well, y to the 15th times y to the 2nd would give me y to the 17th. Now I can rewrite this one as y to the 15 over 3 using rational exponents instead, times cube root of y squared, and that's going to give me y to the 5th times cube root of y to the 2nd. All right, let's try this example. This time I have a number and a variable expression under the radical. So trying this one, let's split this up into cube root of 48 times cube root of x to the 20th. And is 48 a perfect cube? Well, no, but 8 goes into 48, and that's a perfect cube. So I can split this up into cube root of 8 times cube root of what? Well, it would be cube root of 6. And cube root of 8 is equal to 2, so I have 2 times cube root of 6. And then here, 20 is not a multiple of 3, but it is bigger than 3. So let's list some multiples of 3. And we want the largest number in that list that's less than 20. So in this case, that would be 18. So I'm going to rewrite this as cube root of x to the 18th times cube root of x to the 2nd, because that's how many are left over. X to the 18th times x to the 2nd would get me back to x to the 20th. Now I can rewrite this one as x to the what over what? Well, that would be x to the 18 over 3. So that gives me x to the 6th times cube root of x to the 2nd. Altogether now we have 2 outside the radical and x to the 6th outside the radical. So I'm going to write those together, and then I'm going to multiply that by what's left over. Those are both stuck inside the radical, so I'm just going to put them together in one radical. So this would be my final answer. Okay, so that brings up some additional examples for you to try. I guess I have 4 of them here for you to try, so let me slide these over so you can see all of them at once. All right, so here are your 4 examples. So I would like you to pause this video and try these problems, and then after you're done trying them on paper, then check your answers on the next page. Did you pause the video? Okay, here are your solutions for these 4 problems. They should be, let's see if I can get all these on the same screen here. 3, here's number 4. All right, so hopefully you got these answers. If not, please look back at some of the previous examples to see how to do these. If there's a problem with this, if any of these you can't figure out how we got it, or you think I've made a mistake, which is very possible, go ahead and send me an email. Here's my contact information. When you feel ready to take the quiz on radicals, please do. There are 5 problems for you to do, and you need to get 4 out of the 5 of them correct. All right, thanks for watching. Have a great day.